Alright, we're trying to figure out where our police car is going to catch, or how fast she needs to go to catch the stolen truck within 2 minutes. I'm going to do this with a position versus time graph. I know that I want the whole thing to go 2 minutes, so I'm going to just do my time scale so that that's spread out pretty well. 50 seconds there. 100, 110, and 120. So that one's easy to scale. On my position graph, I'm going to think about how far the truck is going to go. It's going 35 meters per second, which is a pretty good clip. In 100 seconds, that's going to be 3,500 meters, and I'm going 20 seconds more than that, so it's going to go pretty far. So I'm going to need this to go up to about 5,000 meters, something like that. So I'm going to try to space this by maybe by 200 meters. There's a kilometer. 2,000. Okay, that should be enough space for us. Alright, so the truck is easiest to draw. It's just in normal CVPM all the way from the beginning to the end. We know at the beginning of the problem that the police officer and the truck are right next to each other. I'll just call that the origin. It doesn't matter where you say it is, but they're at the same place at the same time. So in order to draw this, I'm just going to pick an easy point to calculate. 100 seconds in, going 35 meters per second, she will have gone 3,500 meters. So I'm going to come over on my graph to 3,500 meters at 100 seconds, and then just use a straight edge to make that line. It's a lot easier than trying to do it every second or drawing a bunch of dots and trying to connect them all together. Just do an easy point. You know it's a line because it's CVPM, and you can connect them up. Okay, as for the police car, we know that she starts at the origin, but that she doesn't move until the truck is 150 meters past her. And 150 meters is right about there. So just a touch over 5 seconds, 6 seconds, something like that. So she is going to sit still on the axis that whole time without moving, and then she will go to intercept. We know that at 120 seconds she's going to catch him, so she's going to be here. I can just connect the dots between that initial and final position, knowing that she's going with CVPM. Oops. There we go. So it has to be a slightly steeper line. The question is, what is the slope of that line? That will be our V of the police car. So I can look at the time interval. It looks like this catch. Well, the catch we know is at 120 seconds. Looks like the initial time is about 7.5 seconds. Okay, and the displacement looks to be about 4,200 meters. So the V for the police is delta x over delta t, which is the slope of that line, 4,200 meters over 120 seconds by 7.5 seconds. The units do indeed work out there, and we do the subtraction and get about a little over 37 meters per second. We can solve this a little more exactly, but the idea is that we use the graph to come up with the solution. That's what we're looking for. So, if we find equations for these lines or whatever, we can get this a little more exact, but we've gotten the physics across, and that's the idea. The 37.3 meters per second makes sense because she would have to go a little bit faster in order to catch the truck, since the truck has a little bit of a head start. All right.